Hey guys, today's question is maximum beauty of an array after applying operation. In this question, we are given with a zero index non-negative integer array and an integer k, and in one operation we can choose an index I that has not been chosen before, and we can replace that element by nums I minus k or nums I plus k, both. The beauty of array will be the longest length of the subsequence, not subarray, subsequence consisting of equal elements. Okay, and we have to run the maximum possible beauty of array nums after applying the operations, and we can apply operation only once on an index. We can't repeat operations on a same index, and we can do any number of operations. So we can do a number of operation equals to n minus 1. Okay, sorry, n. Now what will be our approach is, as we can see, we can change the number to nums I minus k, nums I plus k. Okay, and as we have to run the longest subsequence, so the order of the elements doesn't matter. So first we simply sort the array to make it simpler. Okay, so for example, this example is given 4 6 1 2, where k equals to 2. In the k equals to 2, we can replace 1 from 1, choose index 1, replace it from 1. So 6 is changed to 4 and 2 is also changed to 4. So this array will become 4 4 4, and the longest subsequence will be 3. Okay, we can't change 1 to 4, so the longest subsequence is 3. Now if we simply sort this array, this will become much easier. So as I have sorted this array, so it is looking like 1 2 4 6. Okay, now what we will do is, for every index, okay, for every index we will iterate over the array. For every index, what we will do, we will check how further in the right side we can go. For every index, how right side we can go to make this subarray equal. As subsequence doesn't matter, so this subarray can be subsequence or subarray. Okay, so what I will do is, I will, for every index, I will go to the right side and check how much further right side I can go to form this subarray, as it is a beauty of subarray. I mean, this is the as all elements are equal. Okay, and the beauty will be defined as j minus I plus 1. Okay, so for every I will go with j in the right side. Okay, so what we will do, for example, for 1, how much right side we can go. If we go to 4, okay, we will see that we can change these elements. Okay, as the k value of k is 2, for example, if we add 1 to this one, this will become 2, and with minus 2 from this 4, it will become also 2. So 1 to 2 will be 3, and so the most right side I can go for this one is till this element. Okay, and j minus I plus will be 1, will be our answer. Okay, and we will take the maximum of our answer and the previous answer at every step. Now as I come to this element 2, what I will do is, I will again go to the right side. Okay, so this 2 can be converted to 4, and this 6 can also be converted to 4, as the value of k is 2. So we again saw that these three elements can also form that array that have all elements equal. Okay, now when I will come to 4, I will see only two elements, then I will come to 6. Okay, so this is the approach. Now what the simple observation is, for this one, how much right side I can go is simply, as I can take only k elements, I can subtract only k elements, and I can add only k elements. Okay, so for the smaller elements, what should be what should be beneficial for us, to subtract k or adding? Of course adding. So what I will do, I will add k till this point, so it will become 3. Okay, so while this right value, if I subtract k from the right value, if it is less than equals to the 3, okay, which is the addition of the first value plus k, है that means we can take that part of subarray. That means we can change that subarray, that whole subarray, to the all elements equal. Okay, so as this is given num psi minus k and num psi plus k, we will use simply these approaches. So for the value, what will be nums j minus k, which j will be at the right side, num j minus k, while that value is less than equals to num psi plus k. Till that point we can get our answer, and we will increment j. Okay, to check for the next step, and at every step we will simply increment I. So this is something like a sliding window approach. Okay, so let's solve this here to understand more. So first we will simply sort the array. So nums dot begin and nums dot end. Okay, something. Okay, now let's take n as the size, so nums dot size. Now initially let's take answer as 1 or 0. Let's take 0. I pointer at 0 and j iterable also at 0. Okay, now simply sliding window while j is less than n, while the right pointer is less than the size. What we'll do, for every index I which is initially at 0, we will go to the most right side we can go. Okay, so while j is less than n and you have to write the conditions. So the conditions were nums j minus k, as this is the right value, should be less than or equals to nums of I plus k. Okay, that means we can take that part. Okay, now sorry, so answer, while this condition holds, we are in a valid subarray. Okay, that subarray can be taken as the answer. So answer equals to max of the previous answer and j minus I plus 1, which is the length of the current subarray. Okay, and every point we will increment j. Now as you can see, we are not changing the value of j. Okay, j is only going to the right side and I is only going to the right side. So although we are using two loops, but the time complexity is not O of n square, it is only O of n, because we are visiting any element only twice, not more than twice. Okay, and I plus plus at every point. Okay, if I will go to the right side of j, then again j will go to the right side, because this condition will be hold, so we don't need to check for that edge case. Now after this while loop termination, we can return our answer. Okay, let's run this. Okay, let's submit this. So the code is accepted. Thank you for watching, and I can't analyze, but the complexity is O of n.